Hello and welcome. Today we are looking at remove element. This is a great question to go over. It is actually it continues our trend of looking at questions from the top interview 150. Again, these are just a set of questions that come up frequently in interviews. I've seen these often in interviews as well, so really good to know. And the question that we're looking at is remove element. So just to go over the problem statement, given an array of numbers or integers, and also a target, we want to go through and remove all occurrences of that value in place. And so the order of the elements may be changed. We want to return the number of elements and numbers which are not equal to the value. And so basically the new length of our array. And so we want to return k. Now, this is a great problem. You can just tell by the problem description that, it's asking for a modification in place, which if we look at our time and space or memory complexity, it's basically asking for a big O of 1 or constant. So no additional space. This would be trivial if we were to create a new array. The problem would be a little bit easier. And then we're going to go ahead and target a runtime of big O of n, so linear. But just to go over the problem in a visual means, we've got nums. In this example, we've got an array of 3, 2, 2, and 3. Our target is 3. So really what we want to do is we want to go through this array, and in place, we want to remove the number 3. Now the description is a little bit misleading because we don't need to remove them. We can actually just move them to the end of the array, and then we can just simply return how many instances of non-target value that we've moved. So in this case, we would want to just return 2, which would be these items shifted over. If we look at final nums, we see it's basically just 2 and 2. That's the length of our new in-place modified array, or modified in place. And I have an underscore here because it could be anything. We only care about the length of this array up to our non-target values. So again, we're removing the element which is our target of 3. And so again, this would be very simple if we were using additional space, but in this case, we need to do it in place, so it makes it probably a bit more tricky because we need to use the concept of 2 pointers. So essentially, we need a slow and a fast pointer. This question, it turns out, is very similar to the question right below it, which is removing duplicates from a sorted array. It's similar in the sense that there's 2 concepts which correspond, and that is working with arrays and then working with 2 pointers. So again, it's something that comes up a lot and is good to know, especially if you're just starting out and you want to target easy questions. But let's go ahead and define our slow pointer. We're going to set that to 0. So we want to start at the beginning of our array. Now we're going to loop through our nums array. Just good to kind of speak out loud if you're in an interview. And then from this point, what we want to do is we want to start shifting. Now we can modify the array, but we need to do it in place. So what we want to do is our slow pointer starts at 3, and we're going to check for, let me just get this, insert, there we go, freehand. So our slow pointer starts here. We're going to start to iterate. As soon as we get to a value that is not the target, or not our target value, we're basically just going to shift it over and swap it. So our first iteration, this array here, with 1 modification is going to say 2. Oops, let me draw a better 2. It's going to say 2, 3, 2, and then 3. So once we get to this 2 here, we'll do the same thing. We'll shift it over. So let's see what that looks like. If nums I, the current item, is not equal to target. Or actually, we can call this value. We can say val. And then what we'll do is we'll just say, we'll start with our slow pointer and we'll basically just do a swap. Equals nums I. So in this case, it would be on the first element. And then all we need to do is just iterate, or we need to, increment slow pointer by 1. And then we just return slow pointer. So if we look at our example that we had in our diagram in draw.io, we can say remove element. And again, we were expecting a length of 2 for our new array. 3, 2, 2, and 3. Our target is 3. And then let's go ahead and see what we've got here. Node, remove element, 2. Okay, so let's see if we were to, let's add another 2 in there. And this should then give us an output of 3. Awesome. So yeah, again, there's no need to remove the element. It is misleading. It does say remove element. All we need to do is we just need to shift all of the non-target values to the beginning of the array. Again, this comes up a lot. You'll see questions related to arrays, to 2 pointers, and with our solution that we've jotted out or that we've written out, we have adhered to the constraint of the time complexity of O is O of n. It's bound to even though the operation that we're doing, the swap, is O of 1, we're bound to the actual big O or constant time because of our input array, and our memory is actually constant. So we've hit our in-place requirement, and that is it for the remove element LeetCode problem. Thank you so much.